Welcome to The Explainer. Today, we're going on a bit of a mission to radically reframe how you interact with your computer. We're going to peel back the layers of that shiny screen you're looking at right now and check out the raw, uncompromising engine underneath. It's an awesome journey from the illusions we literally click on every single day, straight down to the pure mathematics of hardware. So let's just jump right into it with a pretty wild question. Has the graphical interface reduced us to chimpanzees pushing colorful levers? Sounds harsh, right? But what if our daily routine of pointing, swiping, and clicking is actually holding back our true expressive power? What if the tools we think make computing so incredibly effortless are actually dumbing down our relationship with the machine? To really wrap our heads around this, we have to start questioning the familiar, beautifully rendered world of modern computing. Section 1. The Caveman Interface. Point and grunt. When you look at our sources, they basically pit two totally opposite philosophies against each other. On one side, you've got the graphical user interface, or GUI. This operates on the WIMP paradigm: windows, icons, mouse, and pointer. Critics argue it's just incredibly heavy, requiring massive computational power just to render visual illusions like drop shadows. Then, on the flip side is the command line interface, or CLI. Proponents view this as pure, streamlined reality. It's lightweight, and it offers direct communication with the hardware through absolute exactness and nuanced language. Free software legal scholar Eben Moglen actually called the GUI a caveman interface, based on point and grunt interaction. He points out that with GUIs, we're essentially reduced to animals pushing colorful levers for a reward. If a software developer didn't draw a button for a specific action, well, you simply can't do it. Critics argue we trade the rich, composable nuance of human language for the simplicity of a shiny button, totally sacrificing our ability to express complex, chained thoughts to our own machines. And this leads us to author Neal Stephenson's classic 1999 essay, In the Beginning Was the Command Line. He used these brilliant car metaphors to explain operating systems. He said macOS is like a luxury European car. Gorgeous, but it totally isolates you from the engine. Windows is your mass-market station wagon. Easy to drive, but definitely prone to mechanical failure. But the Linux command line? He framed that as a free, military-grade tank. Sure, it requires specialized training, but it gives you absolute power over any terrain. Stephenson argued that the GUI is basically just Disneyfication. Just like a theme park replaces complex reality with static replicas, GUIs mask the true mechanisms of the computer. When you drag a file to a visual trash can, you're not actually tossing paper into a bin. You're executing a highly complex sequence of binary block reallocations. So let's step away from the messy metaphors of the GUI and enter the precise mathematical realm of the terminal. Section 2. The Cellular Command Matrix, the Monospace Grid. If you strip away all those graphics, what's underneath? It's this incredibly beautiful deterministic cellular matrix. The command line operates on a monospace grid. Imagine your screen filled with large, uniformly sized pixels where every single character cell is exactly the same width and height. Inside this grid, every single cell holds exactly one Unicode code point, along with specific styling metadata, like its foreground color or bolding. And every single keystroke you make in this matrix is a direct, unmediated signal. Press a key and it instantly converts into a raw byte value, like hex 61 for the lowercase letter a. The terminal's line discipline intercepts control sequences natively, like hitting Control-C to instantly send a signal interrupt straight to the operating system. You aren't interacting with a picture, you are compiling imperative text scripts directly into the machine's arithmetic logic unit. And once you accept the CLI as this higher plane of computing, you've got to look at the fiercely loyal tribes who inhabit it. Section 3. The Great Editor Wars. Emacs versus VI. You really can't talk about the command line without bringing up the legendary editor wars. I mean, since at least 1985, this has been a foundational piece of hacker lore. The massive rivalry between users of the Emacs and V text editors was one of the absolute original online holy wars fought relentlessly on early Usenet message boards. This was not just a casual debate over software preferences, folks. It carried the dramatic weight of actual historical conflict. These two sides represent sharply contrasting design philosophies. On one side, Emacs is celebrated as this massive, extensible operating system. But Vim users love to joke that Emacs actually stands for Escape Meta Alt Control Shift, poking fun at how its complex modifier key sequences will supposedly give you carpal tunnel. On the other side, you have Vi, or Vim, which is a modal editor. Emacs users fire right back by joking that Vi basically only has two modes, beep repeatedly, and break everything. The satirical banter here is just fantastic, and it perfectly highlights the incredibly steep learning curves of both tools. Section 4. The Church of Emacs, a Parody Theology. The rivalry actually became so intense, it birthed a real parody theology. The Church of Emacs was founded by GNU project creator Richard Stallman, who playfully goes by Saint Ignatius. And honestly, the absolute best detail here is that the church views V as the editor of the beast. Why? Because the Roman numeral spelling, VI equals 666. You can't make this stuff up. Naturally, V users responded by forming the opposing cult of V, which hardline Emacs purists dismissed as simply trying to ape their betters. V advocates, in turn, are famous for the trash talk that Emacs is a fantastic operating system that just happens to lack a decent text editor. Saint Ignatius himself famously decreed that using a free version of Vim is a penance, not a sin. And this is key, because it shows that while the editor wars were deeply satirical, the core devotion to the free software movement was dead serious. The true sin wasn't using the rival editor. The true anathema was using proprietary closed-source software. But to really appreciate the power of these tools, we have to trace this whole cultural phenomenon back to its raw, primordial origin. Section 5. Techo and Pure Execution, Primordial Origins. To really grasp the power of all this, we gotta go back, way back. Following this timeline, we can see how the modern editor wars actually stem from programmers literally slicing and splicing paper tape in the early 1960s. Before screens even existed, programmers used offline flexowriters to punch code into continuous paper tape. If you made an error, you had to physically cut and tape the paper back together. That completely changed when Dan Murphy, an MIT student, developed TECO, the tape editor and corrector. By the 1970s, TECO was so robust that Emacs was born. In fact, Emacs was originally just an acronym for editor macros, which was a set of macros built entirely on top of TECO. But listen, Techo wasn't like any text editor you know today. Ask yourself this: what if literally every single character you typed on your keyboard was an imperative command? Not just letters, but the numbers, the spaces, the punctuation, everything. Techo had absolutely no syntax. It operated on a principle later coined as Yafiji. You asked for it, you got it. This is the total antithesis of the modern YSIWG. What you see is what you get. In Techo, every character was a command, dispatched straight to an execution routine. It was this raw, imperative language that did exactly what you typed, no matter how disastrous the result might be. There's an old hacker joke that a common game was for users to just type their own name into the Techo command line, hit execute, and then try to figure out what chaotic series of edits just happened to their text buffer. Just look at this exact syntax. This is how you would program Hello World in Techo. You type I for insert, the text, and then hit the escape key twice, represented here by those $signs, to execute. Because of this incredibly dense, cryptic structure, Techo was famously called a write-only language. It was massively powerful for processing text, but reading a Techo program back to understand what it did without documentation, practically impossible. But honestly, Techo proved something huge about computing. Text is quite literally the only way to safely compile our associative imagination down into exact hardware execution. Bringing our journey full circle, the command line and tools like Techo, Emacs, and Vi, they aren't just old technology. They represent the ultimate semiotic bridge. They let us take the messy, continuous associations of human thought and compile them down into the rigid, deterministic reality of physical silicon. So as we spend more and more of our lives interacting with complex, probabilistic AI systems and heavily abstracted graphics, I want to leave you with this final, provocative thought. In a world of statistical algorithms and visual illusions, will you learn to wield the divine deterministic script of text to assert true control? Or will you settle for the caveman interface, simply pushing colorful levers and hoping for a reward? The choice of how you communicate with the machine is yours. Thanks so much for joining me on this explainer, and we'll catch you next time.